Good day everyone. This is Engineer Armando Omanito and our topic for today is somewhat a continuation of the first part of this cantilever beam or computing the peaks and moment of a cantilever beam with and without support at the pre-end. So the last time we tackled a cantilever we tackled the computation of the peaks and moment of a cantilever beam with support at pre-end and with uniformly distributed load. Now this time we will tackle a cantilever beam with support at pre-end and with uniformly varying load. So here is the problem. So by the way, this problem can also be seen in a reviewer book published by a very well-known uh, civil engineering review center. So this is the problem. An 8-meter high retaining wall is subjected to lateral earth pressure increasing from 0 at the top to 138 kilopascal at the base. Flexural rigidity EI is equal to 4.5 times 10 to the 14 Newton millimeter squared. Analyze per meter length of the wall. Number 1. What is the moment at the base of the cantilever retaining wall? Number 2. To prevent excessive deflection at the pre-end, the wall is braced at the top. Find the force kilonewton exerted at the prop end of the wall so that the resulting deflection is 0. Number 3. When the wall is propped at the top, what is the resulting moment at the base? So let's have the solution. So first, we will treat this retaining wall to be a cantilever beam per meter width of this retaining wall. So this will be the figure of the retaining wall. So this is the figure. So there is point B at the base and point A at the top. And the load is 138 kilopascal, or it will now become 138 kilonewton per meter because we will analyze per meter width of this retaining wall. So then we will treat this as a cantilever beam with support, with and without support at the pre-end. So in number 1, we will ask to what is the moment at the base of the cantilever beam retaining wall without support. First, without support at the pre-end. So without support at the pre-end, the moment will be, we will use the usual formula. So this is 1/2 multiplied by, or 1/2 of the uniformly varying load multiplied by the length of the beam multiplied by the moment arm of the load from the fixed end. So that will be 138 kilonewton per meter divided by 2 times 8 meter times 8 meter over 3. And that will give us the moment at B, or the fixed end moment without support at pre-end, to be 1,472 kilonewton per meter. So that's number 1. Now, in number 2 and 3, we will analyze this cantilever beam with support at pre-end. So, in solving that this number 2 and 3 question, we will use this formula in computing the fixed end moment of a cantilever beam with support at pre-end. So, I've been working on this formula that I invented about 2018 and and keep on enhancing and improving this formula ever since, until now that I found out that this formula is correct and accurate. So to answer number 2 and 3, we will first draw the so by the way, the formula that I invented is here. It is equal to the uniformly varying load multiplied by the length of the beam multiplied by the moment arm of the moment diagram divided by the degree of the curve of the moment diagram. So first we have to draw the moment diagram of this beam, of the load of this beam. So to to compute for to answer number 2, and that is to prevent excessive deflection at the pre-end, the wall is braced at the top. So we will find the force exerted at the flap end of the wall so that the resulting deflection is 0. So we will compute for the reaction at A or the support at pre-end. Okay. But first, we have to compute for the fixed end moment of the beam with support at pre-end. So this will be the figure. So there is the support at the pre-end, so that the support will be there and will stay there, but it will not be included in the computation of the fixed end moment of this cantilever beam. So we will just use the uniformly varying load, that is negative 138 kN per meter. Negative means that the moment is clockwise. So multiplied by the length of the beam, multiplied by the moment arm of the moment diagram, divided by the degree of the curve of this moment diagram. So pressing our calculator, it will give us the moment at B, or the fixed end moment now with support at pre-end, is equal to negative 588.8 kilonewton meter. That will be number 3. So by the way, I'm sorry, that is the number 3. So when the wall is propped at the top, what is the resulting moment at the base? So that is number 3. So we will now compute for number 2. So for number 2, using figure 2, so we have here figure 2, this one. So we will compute for the force exerted at the plumb end, or the reaction at the pre-end. So to compute for that, we will be using figure 2 here, figure 2. So in using figure 2, we will have summation of moment at B is equal to 0. So we already have the moment at B, or the fixed end moment with support at pre-end, that is negative 588, plus the load, the moment produced by the load, that is 1/2 multiplied by 138 multiplied by the length of the beam, 8, and then by the moment arm of the load, which is L/3, this one. And then minus the reaction at A, or the reaction at the pre-end, multiplied by the length of the beam, is equal to 0. So the reaction at A will be, so manipulating everything, we will get that the reaction at A is equal to 110.4 kilonewton. So again, we will just compare our answer to the answer in this reviewer book, where we get this problem. So this is the problem, and this is their solution. So we will just focus on the fixed end moment of the beam with support at pre-end. So this is the moment without support at pre-end. So the moment and the reaction with support at pre-end. So they have their answer here, 110.4 kilonewton, and the same with the moment. So we arrive at the same answer. So negative 588.8 kilonewton meter. So that's so to sum it up, I have here the summary of my formula. So the summary of my formula is also similar to the summary of the formula that I use in the uniformly distributed load. So whether it is a uniformly distributed load or a uniformly varying load, you will just memorize one formula. And that is, so for uniformly varying load, that is the moment at the fixed end of a cantilever beam, the moment at the fixed end of a cantilever beam with support at the free end here is equal to W, or the uniformly varying load, multiplied by the length of the beam, multiplied by the moment arm of the moment diagram of this beam, divided by the degree of the curve of this moment diagram. So that's all for today, and I hope that you learned something in our lesson. This is Engineer Armando Omanito. Until next time, and may God bless us all.